So welcome back again to my masterclass formula. So today we're going to do a lesson about general integration, formulas and U substitution. Under it there are some formulas of it. First formula is integral of u raised to n du equals to u raised to n plus 1, and under it is n plus 1 plus c, our arbitrary constant. This is our general power formula. The next is integral of du over u equals to n absolute value of u plus c. Then number 3 is integral of e raised to u du equals to e raised to u plus c. Plus c right here because this is our arbitrary constant. Okay, e raised to u plus c. Then number 4 bit is integral of a raised to u du equals to au over ln of a plus c. That's our arbitrary constant. Then after we know our formula, we're going to have the techniques of integration in the u substitution. First, I have some examples right here. First, to identify our u here. Our u will be this. Let e u equals to ex plus 1. Then our derive it is du equals to ex dx. Then after that, we substitute our e to u and du, and it's not like this. Integral of u du equals to u to u squared over 2 plus c. Then we are substitute it back. Then 1/2 integral of ex plus 1 squared plus c, and that's our final answer. Then I have another example here under the u substitution. Wait. First, we are going to let our u right here. Our u will be square root 1 plus x squared, and derive it. This will be du over dx equals to 2x, right? Then the 2x will be du equals to 2x dx. Then we're going to substitute it by doing this. Integral of 1 over 2 square root of u du. Then we're going to get 1/2, the constant of it. 1/2 times 1 square root of u du. Then we're going to solve it again. Solve this part. So it'll be 1/2 times 2u over 1/2, and substitute it back. Our u right there, right here, so it'll be 1/2 times 2 parenthesis 1 plus x2 x squared plus 1/2. Then we solve this part. There will be square root of 1 plus x squared, and that's our final answer. Then simplify it by adding a arbitrary constant, 1 plus x2 plus c, and that's our final answer. So today we're going to tackle about techniques of integration in integration parts. First, we're going to recall our derivatives of it by d equals to uv equals to u dv and plus v du. Then this part is we're doing as always is we're going to transpose right here, right? Transpose. Then our integral of it is integral of u dv, v equals to d integral equals to integral duv negative integral v du, and this is our integration by parts. And our cite some examples. Sample number 1 is integral of ln x dx. Then this is our dv, right? dv. And this is our u ln u. And u is our u. You write ln x, and dv equals to dx. Our derivative of it is du equals to dxx. Then v is equals to x. Then our substitute and solve it by u v equals to negative du equals to x ln x, and negative integral of x times to dx x, and so go to our x right here, x ln x negative minus x dx, and we'll simplify it by adding our arbitrary constant equals to x ln x negative minus x plus c. Yeah, that's our final answer. And example number 2 is integral of x 3 logarithmic of 2x dx. Then we get our u ln ln 2x over d dx equals to 1/2 v equals to x over 4. Then we're going to solve it is 1/4 x the fourth ln 2x negative integral of x 3 4 dx. Then 1/4 x to the fourth ln 2x minus x to the fourth 16. Solving it right here, and we're going to simplify it by doing this and substitute back. 1/4 x to the 4 ln 2x negative x4 16 plus c, and that's our final answer. So today, after we done with techniques of integration in integral parts, and we are going to tackle about DI method. What is DI method? DI method stands for differential and integral method, and I will teach you how to do it by this example. Solve it is separated by d and I. First, we get our derivative right here is x cubed, and derivative of it is 3x squared. Then derivative of it is derivative of 3x squared is 6x. Then derive it, it's constant 6, and we're going to 0. Then what is I here? Our I here will be sine 2x. Then we are going to derive it. What is a derivative of sine? It's cosine, right? Cosine 2x over 2. Then derivative of cos is sine 2x over 4. Then derivative of sine, this will be a negative cos and negative sine, and our derivative is cos 2x over 4, right? Then Other derivative with is derivative. This is sine 2x 16. Then we're going to put some positive and negative here. Positive, negative, positive, negative, positive. Then we're going to solve by doing this. Right, we solve it by crossing this out, and the answer of this will be x negative x cubed over 2 cos 2x. Then another we're going to solve here. And so this is 3/4 over x cubed x squared sine 2x. Then we solve this another here. This will be 6/8 x cos 2x. Then this negative 6 will be to solve here will be negative 6/16 sine 2x. Then all of this right here, and we will going to copy it. That's the answer of this. Again, integral of x cubed sine 2x dx. Then its final answer will be this, right? X cubed 2 cos 2x plus 3/4 plus x cube sine. By the way, it's too long. I will rewrite it. My penmanship is too big, and we're going to rewrite it by doing this. By the way, our x3 is negative, right? Sorry, negative x cubed over 2 cos 2x plus 3/4 x cubed sine 2 x sine 2x, then plus 6/8 x plus x cos 2x, then plus by the way, we're going to change our 6/8 here, and we're going to get this lowest denominator will be 3. This will be 3. Wait, this will be 3. Get our 3. This will be 3/4 and negative 3/8. This will be sine 2x plus c. And that is it, how to do a DI method. Getting the derivative and integral of this part doing this table, right? And thank you. So today we're going to tackle about trig substitution. The trig substitution has 3 types. The first type 1 is if the integral contains a squared plus x squared, use x equals a tan theta, and this a will be constant. Next, type 2, if the integral contains a squared plus minus x squared, use x equals to a sine theta, or x equals a cotangent equals theta. Then type 3, use type 3, if the integral contains x squared minus a squared, use x equals a sec theta. Then I have some examples here in type 1, using the type 1 in trigonometric substitution. First, we're going to integrate it by doing this. By the way, we're going to integrate it. Integral of square root 4 plus parenthesis 1 plus tan 2 squared. By the way, the equivalent of 1 tan squared theta will be secant theta. And this will be 2 secant squared theta d theta. Then we're going to let this as our x. Sorry, it's too windy here right now. X equals to, let our x will be, let x will be 2 tan theta. Then we're going to derive it. This will be dx equals to 2 sec squared theta d theta, and this will be right here our tan. Then this 4 right here, we're going to take it out. This will be 4 sec integral of sec cube theta sec theta d theta equals to, simplify it, 4 sec integral sec cube theta times sec theta d theta. Then we're going to get the u derivative and the v, the u of this, of secant. This will be u sec theta du equals to sec theta d theta d theta. And by the way, I'm wrong. This will be plus a theta. Then our dv will be sec squared theta d theta, and v will be tan theta. And we're going to substitute it. This will be integral of secant squared theta d theta equals to sec theta tan theta minus integral sec theta tan squared theta d theta. Then we're going to add this by doing this. Will be sec cube d theta equals to sec theta tan theta minus integral of sec theta close parenthesis sec cube theta minus 1 d theta. And we're going to solve this and simplify. Equals to sec theta tan theta minus sec cube integral of sec cube theta d theta plus sec integral of sec theta d theta. Then we're going to solve this by adding this part. There will be 2 integral integral sec cube d theta equals to, this will be adding here 1/2 sec theta tan theta plus ln absolute value of sec theta plus tan theta value plus c, adding our arbitrary constant. Then we're going to simplify this and wait for another one because my phone is full. Then we continue this solving right here. This will be 4 sec bracket sec squared theta times sec theta d theta bracket. Then by this squared here, there will be 1/2 for 1/2 sec theta tan theta plus ln absolute value of sec theta plus tan theta absolute value plus close parenthesis right here and plus c. Then we're going to simplify it by doing this. This will be 2 sec theta tan theta plus 2 ln sec theta plus tan theta plus c. Then we're going to getting this part, we're going to get again the x. The x here will be x equals to tan 2 tan theta. Then we will convert it by, this will be tan x over 2, and we get a triangle, doing a triangle here by Pythagorean theorem. This will be our theta 2, this part is will be 4 plus x squared x, this will be sec theta equals to 4 plus x squared 2. Then after that, we're going to substitute the sec. This will be equals to 2 square root of 4 plus x squared over 2 x plus 2 ln absolute value of square root of 4 plus x squared over 2 plus x 2 plus c. And this will be our final answer. By the way, this is not our final answer. We convert this part by this part. This will be not a final answer. Not a final answer. This will be our final answer. We simplified it again by this part and this part right there. Our x over 2 and x over 2 right here. This will be x over 2, convert right here, 2, 4 plus x squared plus 2 ln absolute value of x plus 4 plus x squared 2 absolute value plus c. And this is our really the final answer. Sorry, because I forgot the simplify bit. X squared is part 2 right here. We're going to get our 2, then this 2 right here, so it'll be x squared Ay, it's 2. Copy the 2 right there. It's 2. Okay, that's why the answer. So long, so hard, but I'm trying my best right here. So, I have another example here in type 2 using trigo substitution, trigonometric substitution. First, we're going to derive this. This will be integral of 2/3 cos theta d theta over 4 minus 4 sine theta. And then we're getting our 3y in dy here. This will be our 3y is equals to 3y equals to, let our 3y to sine theta over then by the way, this will be our derivative is 3 halves cos theta d theta. Then we're going to simplify this part. This will be 2 integral of 2/3 cos theta d theta over 2 cos theta. Then simplify it by equals to, by the way, our 3 sine is equals to, solving this 3 sine, this will be 3 sine 2 sine, will be solving this 3y over 2, this will be sine theta arc sine arc equals to theta arc sine 3 2. And after resolving that, we're going to solve this part. This will be simplify it by 1/3 over d theta is to 1/3 theta plus c, and we convert this part to substitute it. Now theta, the theta is will be 1/3 arc sine 3y plus c, and that's our answer. Then another example here in type 3 in trig substitution. This will be cos 2 integrals of tan theta d theta equals to 4 sec squared theta minus a. Then we're going to get our this part. By the way, this part, this will be equivalent to 2e(x) cubed. Then we're going to get the 2ex by doing this. 2ex is equals to 3 sec theta, and 2 deriving this 2ex dx is equivalent to 3 sec theta tan theta d theta equals to 3 sec theta tan theta d theta over 3 sec theta. Then cancel this out. This answer will be dx tan theta d theta. Then our sec right here. By the way, after that, we're going to get a derivative. Then we convert this. This will be tan integral of tan theta d theta over 3 tan theta. And getting this part, this will be equals to 1/3. This will be cancel out the tan. This the left should be 3 and d theta. This will be 1/3 d theta equals to 1/3 theta plus c. Then the convert our theta right here, right? Convert our theta right here. This will be sec right here. This will be secant theta equals to 2 ex right here, the ex and 3. Our theta right here, this will be arc sec 2 ex 3 equals to 1/3 arc sec 2/3 ex. Then substitute this d theta. This will be 1/3 arc sec 2 ex 3 plus c. Then this is our final answer. So today we're going to tackle about techniques of integration partial fraction. There are 4 cases of partial fraction. The first case is distinct fraction. Distinct fraction is repeated linear factors. This will be n over x minus a, then close parenthesis x minus b, close parenthesis right here, then this will be x plus c equals to a over x minus a plus b over x minus b plus c over x minus plus c. Then the case number 2 is repeated linear factors. This will be n over x squared close parenthesis x minus 1 open parenthesis close parenthesis open parenthesis x minus 1 close parenthesis q equals to a over x plus b x squared plus c over x minus 1 plus b small b over x minus 1 squared plus c x minus 1 q. So the total number of the exponent will the total variable, that is repeated linear factor. Then case number 3 is quadratic factors. N a x squared plus bx plus c equals to a 2a plus b over ax squared plus bx plus c plus b over ax squared plus bx plus c. Then case number 4 is repeated quadratic. This part is so hard to solve. So many uses of techniques of integration, like integration by parts, trig substitution. This part is so very hard for me. N ax squared over n a over ax squared plus bx plus c equals to a 2x plus b over ax squared plus bx plus c, then b plus b a over a squared plus bx plus c, then c 2ax plus b over ax squared plus b x plus c squared, then plus c d ax squared plus bx plus c squared. That is our cases in techniques of integration partial fraction. So many cases and so hard to understand this lesson or topic. This is our cases. So I have some examples here in partial function. Case 1, distinct fraction. First, we have a problem here. Integral of 4 over x squared minus x minus 2 dx. Then the first we're going to do is to get this part. So this will be 4 x squared minus x minus 2. Then we get the fraction right here. This will be x plus 1 x minus 2. Then this will be this part, this will be x, then this part, this will be minus 2x, then in this part is copy our 4 right here. Then after we get this part, we add the negative x right here, negative x, and that is our partial fraction. So we can represent this part. This will be a x plus 1 plus b x minus 2. Stuff like that. So this part is will be integral of a over x plus 1 dx plus integral of b x minus 2 dx. So after we get the a over x plus 1 dx plus b over x squared, we use this part to get our final answer. We use a cover up method. Cover up method. We cover the x plus 1, we cover this part, and x plus 1 and x plus 1 right here. Then the left is will be our a, right? Our a. So let's cover up, then the left is x plus squared a. 4. Our a will be 4 x minus 2. Then our limits there x is 1. Then the b right there, we cover up the x squared and x minus 2, x minus 2 and x minus 2, and the left is x minus 1. 4 x plus 1 equals to 2. Then we solve this part right here, and this will be 4 over negative 1 negative minus 2. This will be 4 thirds, negative 4 thirds, and this another part, this will be 4 over 2 plus 1, and this will be positive 4 thirds. Sorry, I cover up again, if you didn't see, I cover up this in our a. In our a, we cover up this part, is this will be cover up this and this, with the meaning is 4, and this is final answer. Then after we cover up this part, then we're going to minus this 2. This will be negative 4 thirds, same as our b. We cover up this and this, and this and this. This will be x plus 1. Then you need to solve 4 over 2 plus 1 is be positive 4 thirds, and then we're going to simplify this part. After we getting this part, this will be our simplification. Be integral of negative 4 thirds over x plus 1 dx plus integral of 4 thirds over x minus 2 dx. Then simplify this. This will be negative 4/3 ln result value of x plus 1 plus 4/3 ln 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 x absolute value of x minus x minus 2 ln plus c, and this is our final answer. So I have case number 2 right here in partial function. First we're going to do is this will be part is u minus 1 over u, which means u plus 1 squared du. Then we take our partial fraction right there. This part this will be 1 over u plus 1 u plus 1 plus 2 over u plus 1 squared. Then after this we apply our, this will be du, apply some rule right here. What to do is integrate this, all of this. So then this will be integral of u du plus 1 u plus 1 plus du right there plus 2 integral of 2 over u plus 1 2 du. Then after applying some rule right there, this part we integrated, this will be integral of 1 u du, this will be ln of u, and this part this will be integral of 1 plus u will be du, and this will be ln possibility of u plus 1 absolute value, and this will be part is integral of 2u plus 1 2 du will be 2u plus 1. Then we're going to solve this 3 as 2 negative ln negative ln x plus 1 plus ln x plus 1 plus pagid 1 minus 2 over x plus 1 plus 1. Then we simplify this part. This will be negative ln x minus plus 1 plus ln x plus 2 over 2x plus 2, and add our arbitrary constant c, and this is our final answer. Solving this case is so hard to me because I'm trying to adapt the other methods that is in internet, and I'm trying my best. So we have here case number 3. First we're going to do is take our constant out right here. This will be 4 times 1 over x plus 1 cross parenthesis is x2 plus 4 dx. Then after we taking our constant, take our partial fraction right here. This will be 1 over 5 x plus 1 plus negative x plus 1 over 5x Plus parenthesis right here, squared plus 4x. Then after we're taking our partial fraction right here, we solve this part by doing this. Apply our, we combine this part, by the way. So it will be 4 integral, combine this part, 1 5x plus 1 plus parenthesis right here, plus x plus 1 5 x squared plus 4 dx. Then we apply a sum rule right here. This will be 4 plus parenthesis integral plus parenthesis right here. This will be integral 1 5 close parenthesis x plus 1 dx plus integral of x plus 1 over 5 x squared plus 4 dx. Then after we taking this, we apply after we apply our sum rule. Right here. This will be this part. This will be or 4. No. The 4 will be taken out. This will be integral of 1 5 x plus 1 dx is equals to 1 x. No. This will be equals to 1/5 ln of x plus 1 absolute value. Then this part is will be so long. This so long will be integral of x plus 1 5 x squared plus 4 squared dx equals to 1/5 close parenthesis minus 2 ln x2 minus plus 4 absolute value plus ln arc tan x plus 2 close parenthesis. Then we're going to simplify this by doing this. This will be 4 close parenthesis 1/5 ln absolute value of x plus 1 absolute value plus 1/5 over minus negative 1/2 ln x plus 2 plus 4 plus 1/2 arc tan x squared. So this is plus our arbitrary constant c, and this is so hard and so much analyzing to this part. This is an answer, by the way. So I have here case number 4. This first we're going to do is take the partial fraction. So it'll be 4 x squared plus 1 x2 minus x 2 plus 1 squared. Then after we taking the partial fraction here, we're going to integrate and take the sum rule. First we're going to do this is 4 x squared plus 1 squared dx minus integral of x squared plus 1 squared. Then we take a partial function of this. This will be 2 ln 2 right here. So 2 right there. X minus absolute ln absolute x2 plus 1 absolute value plus 1 x squared plus 1. So this will be in this part. This will be close parenthesis x2 x squared plus 1 close parenthesis plus 1/2 arc on x. Then simplify this. This will be 4 ln x minus 2 ln absolute value of x2 plus 1 absolute value plus 2 x squared plus 1 minus x x 2x2 plus 1 minus 1/2 arc tan, then add our arbitrary constant plus c. And this is our final answer. Adapting some methods I see in internet. So today we're going to tackle about multiple integrals. Under the multiple integrals, there will be double and triple integral. So what is double integral and triple integral? Double integral is a function of two variables over a region in the real number place are called double integrals. So a triple integral of a function of three variables or a region in real number of 3D space are called triple integral. So in integral, this will be the graph, right? Integrals give the area number a curve, area under a curve, right? And this is or be the formula of in our integrals. But in our double and triple integral, this will be look like this. Sorry for my sketch, I didn't get by NC internet. This will look like this. Double integrals give the volume under a surface, and the formula will be limits integral of limits c to d, integral of limits a to b, f x y dx dy. And this look like if we graph in 3D, this will be 3D in triple or double integrals, right? Like this. Compared to our integral graph, it's 2D, one-sided. The formula is limits a to b, f of x dx. I said real number in 3D space are called triple integrals, and double integrals, real number in our number place, are double integral. Stuff like that. So then we are going to solve here sample of our double integral. First we're going to do is change the order of integration. To do that, this will be integral 1 limit 0 to 1 and 0 to x squared. This will be x squared minus 1 dy dx. Then to solve this part, this will be x squared, limits to 0 to x squared equals to x squared plus 1 dy equals to x squared square root of x squared plus 1. Then after we doing that, this will be equals to 1 limits to 0 to 1 0 to 1 x squared square root of x squared plus 1 dx. Then solve this part. This will be negative square root of 2 ln over 1 plus square root of 2 plus 6 over 8 square root of 2 plus c, our arbitrary constant. Then this is all final answer. Double integral. So, thank you. So to solve this will be, the first we're going to do is to get our part is this will be equals to integral of 2 limits 2 to 1 square root of x plus 2 dx equals to negative 16 3 plus 2 square root of 3. Then after that, we're going to solve it again. 3. And negative limits to 0 to 1 pi over 2 plus 2 negative 16 over 3 plus 3 2. This will be 2 and 3 square root of 3 dx dy. Then so we're going to solve this. This will be 2 pi over 2 y limits y over 2 negative 16 over 3 plus 2 3 square root of 3 dx equals to pi plus parenthesis 3 square root of 3 minus 8 plus 16 over 3. This will be minus here, minus 2 square root of 3. Then doing that, we're going to negative 0 limit to 1, then close parenthesis pi 3 8 plus 16 over 3, then minus this 2 square root of 3 dy. Then we're going to solve this in this, right? So in this will be limit to 0 to 1 over pi 3 square root 3 minus 8 close parenthesis plus 16 over 3 minus 2 square root of 3 close parenthesis dy equals to pi 3 square root of 3 minus 8, it's a 16 over 3 and minus 2 3. Then simplify this will be equals to pi 3 square root of 3 minus 8 plus 16 over 3 minus 2 square root of 3 plus our arbitrary constant c, and this is what our answer. If you're thinking I'm using other method, I see internet. So that's all for our triple in the world. Thank you.